Today.
This was Michael's request, not my request.
Was it Michael's?
Yeah.
And is he not here today?
But he'll be here.
He's always like 2 minutes late.
Why don't we take out our packets, have those
He's later
handy.
in the office on the
Yeah. So, well, welcome and happy Friday to you all. It is certainly nice to have a Friday. And it's really nice to see you guys 2 days in a row. Hope everybody at home is doing okay, following along. And just want to say today our goal is to get through the questions that I asked you guys to complete last night for homework. Be patient. Some of you will be like, okay, this stuff, I get it. I just want to take it slow for everybody so you have an equal opportunity to ask any questions and that everybody leaves here feeling a little bit better. So even if you are someone that's like, okay, I understand this is pretty easy for me, let's all just take a breath and be patient for everybody so we can all be on the same page. As far as this homework this weekend, your homework for this weekend, if you've noticed and you guys look ahead at all, it says it's a catch-up night. And I don't do these very often, so don't get into the habit of really liking them. There was 2 this unit. I tried to kind of ease you back into the flow of getting back into school and things. So if you are all caught up and you're where you need to be as far as the reading, your vocab chart, your homework, everything, you have nothing this weekend. You can enjoy that 3 days off from my class and fulfill it with all your other homework that you have a million other and 1 pages to get done. But if you are a little behind in any other reading, tonight's or this weekend, probably not tonight, is a good opportunity for you to get caught up. I won't be online at all until Monday, so if you have any questions, I'm just telling you, I won't be checking any emails tonight or tomorrow, and probably not Sunday. So I'm going to take a little bit of time away from work too. So we're going to enjoy some hopefully good weather out there. I think that's about it as far as announcements. Does anyone have any questions as far as like logistical things or anything like that?
Yes, these questions in general.
Okay, Ty had a question about the paper, and we're gonna go over that here in just a second. So yesterday, I feel like I got a pretty good read, you guys, when I was bouncing back and forth from this group to this group, as far as where you were at. I'm not going to go through every single thing that we went through yesterday that I could kind of see where you were falling in line. And if I'm going too fast on any of it, just let me know. So starting with the chart, the mean, median, and mode, I think that's the most basic stuff. I feel like you guys, okay, yeah, we got that. What is a disadvantage, though? I'd like to ask you guys as a class, what's a disadvantage of the mean? Just the mean is what I'm most concerned about. Corinne.
Well, we looked it up and it said it was biased with no meaningful value.
It can be biased for sure. And where is the bias you can come in? Boris?
From like an outlier that's way far away from everybody else.
Yep. So what did your book say? So Boris said from an outlier. Corinne said it can be biased. I'm just repeating because I want to repeat for everybody at home. You guys, what did your book say about, they gave you an example about an extreme case. Does anybody remember the means extreme case in the book? Just doing a little bit of review. It does. So this is what's, so like it's following me. So I don't know. Sometimes if I go too fast, it doesn't catch me. So we'll see if we can get. So what did you read?
From the book?
Yes.
I did not read
Okay.
that part.
Okay. Did anybody in here?
No.
Okay, Riley.
Was it the Twin Towers? Was that the example?
No, it was about a coffee shop. Horace?
It was like the Bill Gates one, like if Bill Gates were just walk into a coffee shop, all of a sudden the median income because everyone's a billionaire. Even though
Yeah,
that's not true.
yeah, that's exactly it. So he gave the Bill Gates coffee shop. In a few years, probably 5 to 6 years, you guys are probably going to be looking for careers. You're going to be out there in that world of adulthood. And it's interesting, as I was talking to another young man who was interviewing for Cottingham and Butler sales, and some of your parents may work there. And if you know anything about sales, the sales force anywhere really varies in your income. And he was told the average salesperson makes X amount of dollars. That's not a really good measurement of what you probably will be making right out of college, because if you think about this, hello Michael, you're on video. So Michael, look at, we have you actually coming into class. How late is he guys?
Like 30 minutes.
10 minutes late. He wanted to be on this video. Here he is. People at home, welcome this young man. But what I was saying is, if you guys are being told, Ty, if you're being told, hey, you can make 60 grand. Well, many salespeople make 200,000, but right out of college you might only make 35,000. That's a pretty big difference. So be cautious when you are evaluating the mean, because it can be distorted by extreme sets of scores. Moving on down beyond that, I think pretty much I went through everybody and we talked about the skewed data. Am I right in this class? So talk to you guys to make sure for you to identify what is skewed, that you know that that's the outlier and that's the way the tail is being pulled. Okay, so they don't say tail on them. They're not going to say tail on if you get a graph, but I'm writing that on there for you guys just so you know. Questions so far? All right, so I should have probably started by just chatting about this a little bit. I added some things from yesterday that I want you guys to know. First of all, descriptive stats and inferential stats in an outline fashion, these are the two big terms. Under descriptive stats are these 2 words. Under those 2 words are these 5 words. So please be sure you can identify that. So if we flip the page, and we're going to start talking about now range. What I want you guys to know is measures of central tendency, and you do need to know this because they will give you a test question. And if you don't already, I mean many of you already do, but they try to trick you on just the wording. So if a lot of you guys would say, well, I can calculate a mean, median, and mode. That's not difficult. But if they give you a test question that says, what is the best measure of central tendency, and they throw all 5 of these terms in here, you should be able to eliminate these 2 terms immediately, because these are not measures of central tendencies. These are measures of variation. So under measures of central tendency are those 3. Under measures of variation are these 2. So what is the range? The range is the highest to lowest, right? And why is that not the best? Range, if you had a choice between range and standard deviation to give you data and give you information about data, range isn't the best, because just like mean, what do we say about the mean? What's the problem with the mean?
It's outliers.
Yeah, so range is most affected by extreme scores as well. So the range isn't going to be the best source of information, standard deviation is going to be better. Okay, so the next thing you were supposed to write down is standard deviation terminology, and I think I walked around and you guys all put how far scores deviate from the mean or are away from the mean. Are you following me on your paper, right? And then what I also want you to include is right here. So I added this. And these are some important terms I'd like you to add just in your own vocabulary regarding standard deviation. Most of you, not most of you, all of you put down the correct answer. We're looking for a small standard deviation. Because a small standard deviation is going to give you good information. And what that information is going to provide for you is this. It tells you that there's low variability in the research, meaning that the research doesn't have a big difference. And so we like to see consistency. That's what it's going to tell you. We have consistency with the data. It's more reliable. You can trust it. So as a teacher, after every exam in here, I will not only give you the class average of every class, but I will give you the class standard deviation. What does that tell me as your teacher? If you have a low standard deviation in this class, But in my 7th hour, I have a same test and a very high standard deviation. I should be saying to myself a couple things. I should be telling myself, I either have some really smart kids in there that knocked it out of the park, or I have some really low-level kids that went down on that extreme and everybody else wasn't there. So it gives the educator, it gives the researcher a good viewpoint of really what's going on with that data, better than the mean would. The mean just tells me what was the average. But I don't know if somebody did really, really well or really, really poor by looking at that. So it gives us reliable data. Questions about standard deviation. You will never have to compute the standard deviation for this class. If you take stats, you will learn how to compute the standard deviation. If you saw it in the book, it's a pretty lengthy equation. Which some of you, as you go higher up in your math classes, I'm sure you've probably already done stuff like that. So then the next thing, if you don't have any questions, I just want to keep pausing, and I'm not trying to make questions, but I also don't want you to feel like you can't ask them. And I also have been in your situation before where I feel embarrassed to ask questions because I'm like, okay, I don't want to be the stupid one asking the questions too. So I hope everybody feels safe enough that you can say, can you explain this to me in a different way? All right, so the next thing you guys were supposed to do is fill this chart out. And the reason why I use color coding, because it just makes sense to me and it helps me a little bit. Don't feel like you have to. But the thing that you must memorize for this class and in the future, if you ever have classes, which I'm sure you will, is the actual percentages. Because those percentages on a normal distribution will never, ever change, ever. No matter where you live in the world, doesn't matter. A normal distribution percentages are always the same. So please remember, we have 68%, 95%, and then 99%. And then if you prefer, you can break it down into the blues, because you just add up those numbers and all of a sudden we are close to 100% there. The brown numbers are what's going to change. So you will be provided with probably a different mean. If I say the mean on your next test was 55, you guys would put that right in the middle. And if I said the standard deviation was 4, you would count up by 4 or go down by 4. Right here, this standard deviation is 15. Does anyone have questions about how I got that number? So you will always be provided with, like, the standard deviation is this is the mean, now figure out the rest. In AP Psych, you're never going to be allowed to use a calculator because they never give you math that's so difficult that you can't compute just on your own or on a scratch piece of paper. The green numbers never change. Those always stay the same. Those are your z-scores. That's telling you how close you are to the mean. So they use the terminology, 1 standard deviation above, 1 standard deviation below. Mike?
The book has it as 13.5%.
Yeah.
Which one should we do?
It doesn't matter.
Okay.
I mean, were you gonna say something, Chase?
It's just 0.5%.
Yeah.
Yeah,
What,
Yeah.
I
Chase?
don't think it matters too much.
yeah, Michael.
Oh, boy. We have a lot of critics in
Oh,
here.
We were allowed to ask questions, Chase.
You still asked it, did you not?
Yeah, but you're not supposed to make fun out of people, Chase.
Chase always wants to argue.
Does he? Is he a bully?
It is.
There's usually a bully in every class.
It's me.
Mm.
Every class.
I don't like it.
Would you concur, Boris? Is he a bully?
No.
Chase the boy?
Yeah.
No, Chase is nothing but nice to me.
All right. So what I want us to do now is to just look at that next page. Your answers here, and did we leave off here? Is this where the bell rang, or did the bell ring? Do you guys remember?
For us, the bell rang on the inference.
Oh, so we got through this whole next page. Okay, so I think your answers were all correct on that next page. What percent of scores fall with 1 standard deviation above and below the mean? That was 68%. I'm reading these out loud now for people at home too. What percent of scores fall within 2 standard deviations above and below the mean? Our answer is 95%. And then if you can just memorize that chart, you can answer anything. And then 68% of the population will fall between +1 and -1 standard deviation. That's how you can word that. All right, frequency distribution and histogram. The only reason why I put that on there is because you will see a test question or two with that terminology, so you need to know what that is. And in the past, I did not. I assumed kids knew because it's such a kind of like a small little thing, and tons of kids miss that test question about a frequency distribution. So I'm like, okay, just this is what it is. It's a table, right? And what's the benefit of the table? So you're supposed to put like 4 to 11 and then count how many times 4 happened, how many times 11 happened. Not too difficult. What's the benefit of that, Sophia? Of a frequency distribution? I did not mean to catch you like that. I'm so sorry. I don't mean to do
It
that.
shows like how often like the numbers appear.
Yeah, so it looks for patterns in your data. Helpful when you have a smaller amount of data. But then a histogram, which your histogram should have looked like a bar graph just touching. The benefits of a histogram, it's very beneficial, much better than a frequency distribution if you have large amounts of data. It gives you a quick snapshot of comparisons as well. So that's beneficial to be able to see the trends. Moving on. I'll wait a second here. So the next question is asking you, what's the difference between descriptive stats and inferential stats? Remember I said, in an outline fashion, if you take notes in an outline fashion at all, if any of you are note takers, this is kind of a good way to do it because it helps you organize things. So inferential stats and descriptive stats I put over here. This helps you just describe the data. That's it. So you have the numbers. This is what the numbers look like, right? This is the number we got for these tests. This is the number we got for these tests. Inferential test, on the other hand, is going to allow you to make comparisons. It's going to allow you to make sure, is this an actual valid hypothesis? Or should we actually throw this baby out the window? And the big word you need to understand for inferential stats is statistical significance. That word is directly related to inferential stats. So that's why I asked you guys, could you please write down what does the term mean in the book? Because I feel like that's kind of not as clear as us just talking it through. So Leah, could you please do us a favor and read out just the book definition of statistical significance?
A statistical statement of how likely it is that an obtained result occurred by chance.
Yep. So let's break that down a little bit. When we talk about what is the statement, it's going to be a number. If you take stats or sometimes even in higher level research classes, it comes in the form of a p-value. We will not be computing those for our class. It's going to tell you, is there a statistical significance in this research or not? What does that mean? This. If so, the results are not due to chance. Underline, highlight, circle that baby. And I know it sounds so simple, but if you just write down, not due to chance, you score on every FRQ I've ever scored for the College Board. That's what they want you to say. So let me explain what I mean by that. If we had two groups, you guys are my control group, you're my experimental group. I'm going to multiply you 5 people by, we're going to have 500 people over there and we have 500 people over here. Are you following me? All right. Control group and experimental group, I want to do some type of study on memory. Who's going to receive the treatment? The experimental group, right? You guys. I'm going to give you guys music. My belief is if you listen to music, you're going to have a better memory. You guys don't get music. Everybody's following me, right? All right, I get my numbers back. All these numbers are coming in from the memory test. Could there ever be a chance, even through random sampling, that somewhere along the line, one of these groups has a crazy amount of really, really smart people in it? Just by chance. And then what would happen to my data? It could be, right? And so when I get my results back and I look at my 2 means, and I'm like, they're not reflective of what my hypothesis was stating, because when I calculate it and I see my statistical significance, the means are so far apart that all of a sudden we have it due because of chance. It was just some fluke. It was some random thing that happened that caused that number. So in statistical significance, we want a small difference, never. Not like standard deviation, we want a larger difference. The larger, the better. That's gonna show me, even if you guys didn't listen to music, but you guys were all brilliant people and you scored great on your memory test, and I got these results back and I'm like, crap, I really thought music was gonna do that for us. It's going to show us we need to maybe retest, repopulate, redo something here, because we cannot have a lot of confidence in that study. So you need to know this. The small difference shows very little confidence in the validity of the study and how valid it is. The larger the difference, more confident or more experience that you can say, I feel really good that this is a good study. Now don't confuse that with standard deviation. Because standard deviation, you want it small, but with statistical significance, we want large. Larger is better. Does that clean up some of the statistical significance? So they'll ask, so you are not going to have to compute, like I said, but they'll say things like this. They'll say, this study, and they'll give you a ton of numbers, and they'll say, after the results, the study showed there was no statistical significance. You need to be able to infer what that means. Or they'll say it was high statistical significance. You need to be able to understand what does the inference of that statement mean. Leah, I'm keeping you up over there, sister. It's Friday. We got to be excited about something. All right, questions. Then let's see what we know. The next 2 pages on your own, there's a front and a back on that first. There's 4 questions, and then there's like 3 more questions on the next page. I would like you guys to go over it, and then I'm going to give you your answers. Last period, I had kids that finished this quickly. I had kids that took a longer time. I waited until everyone was done. So when you're done, just chill, just relax, and be patient. I'd also like to tell you, number 4, if you guys flip it over, just give me a second and I'll let you work. The graph did not show up. So you need to be able to answer that with this graph. I just recorded it on the board for you. All right. So at home, go ahead and give that a shot. Check yourself for understanding. This page here, and then the next 2 pages. And then we'll go over the answers. just relax, take some time off, take a little break. Others, just keep working. We'd like to have everybody's answers. People at home, this is second hour today. Everybody with the minutes. Even Ava way up here. Yes, and how ugly. I think sometimes I rush things too quickly, and I really appreciate you guys being patient. And yeah, so giving everybody the same opportunity. We all process things differently, and it's really important that we acknowledge that. So, all right, let's go through some of these answers and then ask any questions that you might have, and then we'll wrap it up here. 1, when Ms. Jennings analyzed the grades on her last psych test, she found that the scores had a very small standard deviation. This would suggest what, Chase? And that was an example I used in class too.
Scores tend to be very similar to one another.
Yeah, D is as in dog. Nice job. The correlation number 2 between two observed variables is 0.84. From this, it can be concluded what, Michael Garrett?
A,
What one?
A,
Did you say B?
yes.
Is Michael Duex helping you?
No, I'm just.
Why are you staring at him?
Look,
Getting his head really.
Oh, don't do that. That's not nice. B as in boy, you are correct.
oh, it's like in the book.
Nice job. And last period, yeah, we can flip it over. A student didn't feel comfortable, and this happens a lot. I'm not quite sure why it's B. If you don't feel comfortable asking, like within a large group, just wait after class, and I can show you very quickly why that answer is B.
Yeah.
Yeah. So, okay. Remember the other day when we did correlation, and I told you plus and minus tell you direction of the variable. So, if it's a positive, the two variables are both going down or up, correct?
Yeah.
If it is a negative, one variable is going up and one variable is going down. So this told you negative 0.84, that means it has to be this. So you have to then say, well, as one increases, the other one decreases. Any other questions? Good. 3, what measure of variability provides the most meaningful information about the following set of scores? Ava?
Is it a C?
It is not C, because even though you're correct by saying measure of variation, your choices were range and standard deviation. Range is too affected by your outliers. So just remember that one. So standard deviation is always the best choice, usually. And in our class, it will always be the best choice. Any questions? Okay, you could eliminate mean, median, and mode right away because of what I said. Those are measures of central tendency, right? So that question was asking measure of variation. Number 4, what does the figure of distribution between these two groups suggest? And the figure is up there. Answer for that, Ty. Sorry.
I just said C.
Okay, and the reason why it can't be C is because a correlation. How did I tell you you're going to show a correlation? What's this called? A scatter plot. Is that a scatter plot? Nope, so we can't have that be the answer. Michael Duex?
I said A.
It is correct. Did you have any others that you were a little bit maybe could be?
Me?
Yeah,
Um,
or were you for sure it was A?
I was pretty sure.
You were pretty sure?
I didn't know what bimodal was.
Oh, bimodal just means one set of data with 2 curves, like 2 humps. This is 2 sets of data.
Okay, so then no.
Yeah, but let me give you the answers on the next page real quick so that you can just double check, and if you have any questions, stay after class. Number 1 on the next page is 75 to 85. Number 2, 70 to 90. And number 3, 4%. Have a great day. Have a wonderful weekend. I'm going to let anybody that needs to go. If you need to stay for some questions, come on up.
Wait.
Yes.
So for the second one, if it's talking about the standard deviations of like the mean.
Yes.
And if it talks about the range too, wouldn't it be like 90 and 70 and then the difference between the range?
No, it's just saying, okay, so this is a good question for clarifying points. So, if you look at this question, it's saying, I know, and it's gonna get loud in here, but take off, you guys, see you later, come on up here, Ty. So, if a student scores within 2 standard deviations, these never change, ever, right?
That's what I.
Okay, what's the range of the scores? The brown is the score. So, range of the score is 80, so it would be range of that.
It is statistically different.
This is the score, this is the average.
You know, honestly,
So that's what
that's
it's
a
asking.
really good
And then our
question.
students.
That's so hard.
We go to
I don't think I ever said it. I think it just said that.
And this is how I every single time for myself. Okay, so now it's saying, what is the range of the scores from here to here? That's what
So wouldn't that be like different or is that just?
it's just saying, it's the other way to use the term, like, it's the range of what you think the score is. It might go kind of
I also.
yeah.
I said 5% on the. No, what did I say in the last one? What was the answer?
4,
I said 5.
because
like, look, it
it's 2
says-
point.
It's
If
nine-
you, and this will always be a multiple choice,
Oh.
and it will never, ever be that close.
Okay.
It'll just be like, okay, what's the closest dang thing to 5? And it'll probably say like a 4 point something.
Okay, that's good.
Mhm.
Wouldn't it technically be like a 4.3?
4 point, yeah. I think.
Because it was 0.1 and 0.1.
You guys have a good weekend. Goodbye at home. La 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 la. See you.